Assalamualaikum. This is a review on one of the questions from our tutorial carboxylic acid. I'm going to review question 1 only, and hopefully the rest of the students will share their answer on question 2. First and foremost, let's refer to question number 1. Okay, thanks to Nolaidi for sharing this answer. Okay, for question 1, you need to convert the structure into the IUPAC names. For question A until question F, you are only given a condensed structure. As you can see here, the condensed structure is being drawn in one line. There is no showing of branches and so on. Therefore, the first thing you need to do is you're going to redraw back the structure. Alright, you need to redraw back the structure. If we convert the structure, we'll notice that the first carbon belongs to the carboxylic acid. Whenever it is written as CH, meaning that there is a branch to it. So in this case, at carbon number 2, you will notice that it has attachment to the methyl group CH3 because the CH3 inside the bracket. This is a normal chain, CH2 is normal chain, while for CH3 normally indicates that it is located at the end of the carbon chain. So therefore, if we convert the structure, it will be looking like this. This is the first carbon, second carbon, third carbon, and also fourth carbon. So we come up to the name. Okay, always consider first one is functional group, second one is the longest chain. Luckily, since this is carboxylic acid topic, we knew that carboxylic acid has the highest priority compared to other organic compound. So, longest chain in 4, it will become butanoic acid, and then there is a substituent located at the second carbon, which is the methyl group. So, the name will be 2-methyl butanoic acid. Same goes with the rest of the condensed structure. I would like to highlight a few about C6H5 and also pH. Both C6H5 and also pH technically referring to the benzene attachment. Right? Benzene itself, the formula is C6H6. However, one of the bonding with the hydrogen has been replaced with the attachment to the parent chain. Therefore, we're going to eliminate one of the hydrogen, so it becomes C6H5. pH stands for phenyl. So do not confuse whenever you came across C6H5 or pH, it is referring to the benzene group or the phenyl group. Okay, let's refer to the C. You will notice that C6H5 is being named as phenyl. Alright, in this case, as you can see, the phenyl etanoic acid, okay, the structure given is here. Okay, this is the structure. Alright, and as you can see here, the first carbon belongs to the C double bond OH because this is the main functional group, and then the benzene attached to the second carbon. That's why the answer will be 2-phenyl etanoic acid. Alright, phenyl acetic acid is considered as the common name. So for this question, which require IUPAC name, you can use phenyl acetic acid. Okay, as you can see here, this one is phenyl. Okay, this is the first carbon, second carbon, and so third carbon. Again, please take note that the first carbon belongs at the C double bond OH. So there is substitute at carbon number 3. That's why the answer will be 3-phenyl propanoic acid. Okay, for question E, CH3, the first carbon again, located at the first carbon, the same thing, the longest chain, identify which one belongs to the parent chain and identify which one is the alkyl attachment or substituent. So everything again located in the middle with a bracket, it will be considered as the substituent. And every carbon which is located in the middle should have the formula of CH2. Alright, however, since it is only CH, we assume that this carbon has an attachment. Same goes with this one, the formula should be CH2. However, it only written CH, meaning that it has attachment to the bromine. So we draw back the structure, it will become 2-bromo-3-methyl butanoic acid. Moving on to F. Okay, let's refer to F. For compound F, we'll notice that there is two COH group. So you can numbering from left to right. And of course, you can number it from right to left. It will give the same number of carbon. And of course, the position of substituent is also located at the same carbon, which is carbon number 3. So in this case, we have 5 carbon. 1, 2, 3, 4, 5, the parent name should be pentane. Alright, yang ni saya correct lah. Okay, it's both pentane. And then the position of the COH is located at carbon number 1 and also carbon number 5. We put dioic because there is two CO double bond carboxyl group. So the parent name will be pentane 1,5-dioic acid. And then the substituent is located at carbon number 3. So in this example, please take note that we're going to start counting the number starting from the carboxyl group of the COOH. Alright, we don't start here. We don't start here as number 1. We start from the COOH and then end up as carbon number 5 also at the COOH because it is located at the end of the carbon chain. So substitute is located at carbon number 3, so it will be 3-methyl pentane 1,5-dioic acid. That will be the name. And in the G example, as you can see, okay, you have two options whether you're going to name it as 3-pentanoic acid or pen-3-enoic acid as the parent chain because we are referring to the location of the double bond also. Remember, for double bond or triple bond, the name of the substituent will be inserted inside the name of the parent. Okay, untuk H, numbering okay, make sure start the numbering from the carboxyl group. Carboxyl group is referring to the COH. Okay, instead of numbering 1 here, dekat iodine ni, okay, dekat iodine ni, dia sepatutnya start pada COH ni. So this is number 1, number 2, number 3, number 4, and number 5. Please refer the rate numbering. Alright, technically the parent name, okay, parent name instead of butanoic, it should be pentanoic because it is 5 carbon chain. So sepatutnya pentanoic acid. Pentanoic acid. Okay. And then the position of the substituent is at 2-iodo and also 3-methyl. Okay, for this one, okay, the first carbon belongs to the carbon of the benzene, which is attached to the carboxyl group. So this is 3-chlorobenzoic acid. Whenever we have a benzene attached to carbon, okay, make sure it is referring to the name of the benzyl, and we have the carboxyl group. That's why it become benzoic acid. Alright, J, no problem. Okay, again, first carbon is at the COH at the benzene. So whether you want to go clockwise or anti-clockwise, it will give the same position of the nitro compound. So the answer will be 2,4-trinitrobenzoic acid. Benzoic acid, again, it is referring to the benzene which is attached to the carbon. And following to the K, refer to the K. Okay, this is also example of a dioic compound. In this case, you have two options actually. You can number it from left to right or right to left. However, the numbering starting from the left is preferable because of the substituent. Although both substituent will be located at third carbon, if we number it from left to right or right to left, ethyl is the preferred one because of the alphabetical order compared to the methyl group. So instead of having 3-methyl, we're going to prioritize the ethyl group, so it become 3-ethyl and 6-methyl octane dioic acid. Take note that we are using the full name of the alkane if the compound having more than 1 COH. Alright, and lastly, for I, you should notice again, just like the case in H just now, we need to number it start from the main functional group, the carboxyl group. So this will be carbon number 1, followed by carbon number 2, number 3, number 4, and number 5, whereby the CH2CH3 will become the ethyl group. Therefore, the name will become 2-ethyl. 5 carbon chain will be pentanoic acid. in general, okay, whenever you want to name an organic compound, always take a look at the functional group first, followed by the longest chain. If you follow this guideline, inshallah, we're going to come up with the correct answer. That's it for the review for this question. See you guys in the next video. Thank you.